Kia ora team, this is Mr. Dharma, and today I want to talk to you about kinematics. Kinematics is a study in physics on motion, and we use calculus often to describe it. So kinematics has things that are distance, a function according to time, velocity, a function according to time, and acceleration, a function according to time. What we can do is we can, given a distance function, we can differentiate down from distance to get velocity and then further differentiate to get acceleration. Similarly, we can anti-differentiate up from acceleration to get velocity and then distance. So given a function, you can differentiate down from distance, or you can anti-differentiate up from acceleration. And it sort of helps for you to note that anti-differentiation starts with A, and that's where you start, and differentiation starts with D, and that's where you start. Okay, that's really helpful. So let's quickly have a look at an example. Suppose I gave you a function. I said to you the distance of a particle from a certain point is 3t plus 7. Okay, well, what is the velocity? Well, the velocity is just equal to the derivative of distance, because distance over time is velocity. So you notice that this velocity is a constant. Sometimes people like writing it ds dt equals v, and dv dt is equal to a, d squared s dt squared is equal to a, but I don't really like to get into that because it's a bit funky in notation in level 2. But this is something you'll use later on. But if it kind of helps, notice that velocity is always in meters per second, and acceleration is in meters per second. So that's meters per second squared, and that's why you have this kind of form. Let's try an example where we might need to work something out. So given the function for distance from a point is in maybe meters, is 3t squared plus 7t plus 5. If I wanted to find the distance traveled by a particle at 3 seconds, I can just plug in 3. But I could find the velocity by just differentiating this, 6t plus 7. And so if I wanted to find the velocity at 3 seconds, the velocity is going to be 18 plus 7, that is 25 meters per second, or whatever the units I'm using. In this example, all of them are going to be meters and seconds because that's easy for me to work with. But maybe it's minutes, kilometers, hours, you choose. Now, what if I asked, well, what is the acceleration at 3 seconds? Well, I could differentiate this again and I get a constant 6. And so regardless of the time, the acceleration is constant. Okay, so whatever time I plug in, the acceleration will be constant. And that's because I started with a parabola whose double derivative is a constant. Okay, but it's possible that if I had a cubic, then my acceleration function would also be dependent on time. Now, I can anti-differentiate. So if I were to give you the acceleration of something was this, then if I wanted to find the velocity, I would anti-differentiate, add 1 to the power, divide by the new power, add 1 to the power, divide by the new power, plus c. Sometimes we're given information to find that c. So if I said to you, we know that v of 2 is equal to 7, right? Then what we could do is we could plug in 7 equals 2 squared minus 3 times 2 plus c, and so that's 7 equals 4 minus 6 plus c. That is the same as 9 equals c. if you do the maths. And so now I've got a particular solution for the velocity is t squared minus 3t plus 9. Okay, so given initial points, something like this, you can work out the constants. Now, if I were to continue this and I said, let's find the distance, I can anti-differentiate this and go forward. So add 1 to the power, divide by the new power, add 1 to the power, divide by the new power, add 1 to the new power, plus a constant. This time it's going to be a different constant. So for different constant, I'm going to write d, okay? Because it's not the same c as I had before. And suppose I was told s of 0 is equal to 5. I can plug 5 equals 0 cubed over 3 minus 3 times 0 squared over 2 plus 9 times 0 plus d. And so all of this goes away. So I'm left with 5 equals d. So that means my distance equation is equal to t cubed over 3 minus 3t squared over 2 plus 9t plus 5. And now I've got the original function. Now these bits of information will be given to you in questions or in context, and it's really important for you to be able to pick up and read that. Okay, so you've seen me both differentiate when we're trying to find accelerations and velocities given distance, and we've anti-differentiated when we started with acceleration. One more thing, the same kind of questions can happen. Since velocity is the derivative of distance, you can look at when distance is increasing or decreasing. You can look at when things are stationary, when they're not moving. If something's not moving, what's the velocity? 0. I want you to unpack this and try to apply this. All the best, Mr. Dharma.